All right, hi everyone, and thank you for joining us for Data Engineers Lunch. Today we have a special guest speaker. Karthik is going to be presenting Bodo.ai, and he is, and I apologize if I'm mispronouncing that. Oh, I see, it's just a typo on the screen. He is a principal solution architect at Bodo.ai and looking forward to learning about its capabilities and how it can be used in data engineering. The co-organizers and organizer for this event is Raul Singh, Arpan Patel, and myself. And we are always looking for guest speakers, sponsors, and members. So if you or someone you know would be interested in learning from a webinar like this, definitely encourage them to join us every Monday here at noon, as well as anyone who would like to present on a technology that helps in data engineering. We learn a lot of technology for the first time and then present it here. So if there's some interesting piece of technology out there that you'd want to learn and then present on, definitely reach out to one of us. Our emails are listed below, and we can get you on a guest spot, much like Karthik is today. We are a part of a larger community. Data Community DC is a diverse and inclusive culture that encourages and supports people of all races, gender, sexual orientation, and we expect respect to be given to those protected classes as well. So you can find out more about Data Community DC at their blog, as well as other events, including this one and some of their sponsors. And what we cover here is everything related to data and data engineering. So it could be anything from sources to ETL to how that data is used then and analyzed. So broad range of topics can be covered here in technologies. Keep that in mind if you would like to present something. This is a point in the intro where we encourage any new joiners to kind of share their camera and audio and tell us a little bit about yourself and what you do with data. All right, I won't pull any teeth here. It is Monday morning, so well, for me it's the morning, but I get it. Group roles, if you have a question, please ask it. Be polite and courteous to others and share what you know. Karthik, you can go over any specific ways you'd like the questions to be asked. Sometimes speakers like them in the chat. Some speakers are okay with just unmuting at any point. So just let us know how you would like questions to be handled. Here to not, we deal with real-time data platforms quite frequently. Our main focus is Cassandra, as well as Spark and Kafka, and scheduling with Airflow. So data engineering, something we are very involved with and do daily. DataStax is also a partner and sponsor, as well as George Washington University, some of the other sponsors. And if you or someone you know would like to sponsor this event, you could get a shout out here as well. 15-second announcements. If anyone has any jobs, meetups, or hackathons coming up, you can use this as an opportunity to promote your own event. Doesn't seem like it, so we can continue. One of our own announcements, Anant is hiring full-time or part-time positions for data platform operators, architects, and engineers. So you can learn more at careers.anant.us. And some upcoming events we have, deploying Cassandra using BSE operator to Kubernetes, as well as Apache Livy coming up. Those will be every Monday. We also have a sister meetup to this called Cassandra Lunch that takes place every Wednesday at the same time. Different link. You can find all of our events listed at anant.us/events. And that is all I have for my intro. And Karthik, you can go ahead and take over and stop sharing my screen. And thanks for taking the time to share your knowledge and teach us about Bodo.ai.
Thank you very much, Josh. So can everyone see my screen?
Yeah, I can see it.
Okay, all right, thank you. So, a quick introduction about me. I'm Karthik Narayanan. I'm a principal solutions architect here at Bodo. Um, before Bodo, though, I was with Cloudera for 5 years as a solutions architect there as well. So, I've been in the data space for a while now, and started with Bodo like roughly 3 months ago. I think it started in August, so actually 4 months now. It's been that long. Just a disclaimer, I'm a bit new to the Pythonic side of things. So when it comes to pandas and all of those libraries, I'm still learning. Uh, I come from more the PySpark, Spark kind of world. For the last 5 years, I've been there. So what I'll be doing is I'll be introducing the our platform, Bodo, right? Bodo in Persian stands for accelerate, or to go faster, and that's what basically it provides at the end of the day. And we'll kind of see how it does that as part of this discussion. The website for Bodo is at Bodo.ai. If you go here, you can kind of know most of the details about the company. There's pricing, there's resources, there are trial links. We have trial links for you to use Bodo on AWS. I think Josh asked about open source. Currently, this is not, but you do have a community edition where you can try Bodo on up to 4 cores free of cost without having to go through any licenses. So if for smaller use cases, it's more than enough, right? Uh, um, and So basically, what Bodo is, right? What is Bodo? Bodo is think of it as a distributed platform, right? So we are kind of very similar to what Databricks offers you, or Dask offers you, or Ray offers you, right? They all offer you a way to take your Pythonic workloads and kind of once your needs go beyond a single core execution where you want to go and distribute this across a larger data set on several CPUs, and these solutions provide you a way to do that, right? So Bodo is one such solution. The only difference Bodo has from all of these, and we'll see through it as we go through the slide, through these slides, and then I have some demos prepped up for you, is that Bodo is pure Python. You're using pure pandas at all the time. You do not have to go start using different APIs. For example, if you have to go to PySpark, you would have to go and change your coding and your data frames to something that works with PySpark, either koalas, or basically convert your code to PySpark. Same thing with Dask or Ray, right? Uh, Bodo is pure Python. That means you do not have to change anything just to scale your application, right? Uh, Bodo currently it was founded by this guy here, this gentleman here. He has a PhD from UIUC with multiple years of research in high performance computing, parallel computing. He started Bodo when he was at Intel Lab. Uh, Basically, the reason for him to working or starting with Bodo was that he saw there was this kind of a simplicity and performance gap uh, uh, from a data engineering perspective, right? So when you look at these analytics applications, most of the time the practice that they get started development is started on a smaller data set on your laptops, and then you kind of try to scale it out later. But then that aspect of scaling, going from this small set problem to a large scale uh, problem solution is not easy and was very difficult, right? And there was this gap between simplicity and performance. That means, for example, if you look at a solution like this, right? You have something on the left-hand side, which is very simple, like a pandas data frame kind of an operation, very easy to get started, very easy to use, but then it's slow and then just runs on a single core, right? You cannot really scale that operation out. On the right-hand side, if you want to really get that performance, you have the low level um, coding, like if you want to use C++ or Fortran. In this case, they've used Fortran with MPI, which is what Bodo is based on. The clustering is based on MPI. which stands for message passing interfaces. Right? These are fast and scalable, but creating or writing this code is not easy. You need really, trained MPI uh, developers or low-level coding developers to kind of go through this. The other problem is agility, right? It's very easy to kind of deploy and multiple versions of this or improvements to the high-level coding here very easily. Within a matter of days you can move on, but on this side it's not really agile. It will take you several months of iterations to get and improve on your features that are available. So this is fast and scalable, but very complex and very difficult to maintain. It's simple and simple, very easy to start, but it's slow, right? And especially when you have to go across multiple data sets. And sorry, I forgot to mention about my questions preference. If you have a question at any time, just unmute yourself and shoot. This presentation is not long, so we won't run over time for sure. Okay. The other thing that they saw is that there's a lot of options out there that that people use for developing their analytic applications. But most of the time, like a high percentage of this uses Python. And that's what I've seen at Cloudera too, right? When we started at Cloudera, was a lot of MapReduce that you would see, Java based. But then slowly, as the platforms matured, we kind of see this leaning away from Java. It's a lot of Scala nowadays. There's heavily Python being used with PySpark being available. And then there's also a lot of SQL, right? So SQL and Python seem to have taken over that, what data scientists and data engineers like, because they're very simple to write complex code. And there are solutions out there that can allow you to scale it to multiple um, cores and machines if needed, right? So it's very easy to get started and also very easy to scale, right? And that's where the middle approach comes in, right? That's where the big data approach came in, right? So you had this MPI side of things, which was very complex, and there was this, the regular simple single, Pythonic pandas kind of world, which was very fast to develop but not scalable, right? And then there came this middle approach with MapReduce or distributed computing with MapReduce kind of a paradigm, right? Which is what Spark is based on too, right? Underneath, it still does mapping and reduce. So what you have is you have kind of this kind of a driver executor kind of a framework, right? Where there's a driver, which is kind of the first thing when you submit a code here, it kind of builds an execution plan of how I'm going to do this complex piece of analytics, and then builds several tiny tasks and then sends them into these executors that run these tiny tasks and then collect the results and give it back either to other executors or to a driver to kind of combine things together and give you the results that are needed, right? So there's this complicated dance of tasks that are happening. The problem this is that though it scales, it's very simple to scale, very easy to get started, that it still is not parallel computing. It still is not using your resources very efficiently, right? What you're doing is you're creating tiny tasks that execute sequentially. There's still not pure parallel processing that's happening there. The task scheduling creates unnecessary overheads as well. There was this customer that I used to work with, and we would see that most of the time Spark, like on a job that runs for let's say 10 minutes, 5 minutes is spent in the creating those tasks and submitting those tasks. So there's a lot of CPU overhead with this kind of a process, right? So what Bodo does is, sorry, before I go there, the other thing we saw notice is that most of these, especially Spark, they are not pure Pythonic implementation. There's no kind of a actual, like when you do pandas, you actually, the moment you run the code, pandas, the Python part of pandas is actually running the algorithm to give you the output. Instead, on the Spark side, what is happening, and even same for MapReduce, that they're more SQL-ish kind of frameworks, right? There's this lazy evaluation happens, have large declarative syntaxes in your code. So basically, what is happening internally is that you're writing Python on the top, looks like Python, but the actual execution is more SQL-like. That means to do simple operations, you have to write really long, expressions within basically you take a Python code that is very simple, you have to convert it to a really long SQL kind of expression and then execute it. That's what basically Spark does underneath, right? And that is what causes this long delays and it basically not the most efficient solution to do your data analytics, right? Bodo, on the other hand, is purely Pythonic, right? You have a pandas kind of code, right? This is your regular pandas code. To make it Bodo-ized, there's not much you have to do. You basically install Bodo by doing a conda install Bodo, create an environment, import Bodo, and just add this decorator on top. At this point, this code is Bodo-ized, right? What I mean by Bodo-ized is that it not only so when you install Bodo, Bodo is, I'm sorry about that. Okay. Sorry about that. So Bodo is doing a couple of things, right? First, it's taking this simple code, and I'll go through the details of it. That it's not only is it making it distributable, but it's also what you're doing is optimizing it, right? It takes this and it runs it, basically does a compilation of this code and converts it to more optimized parallel optimized code that is capable of executing in parallel, right? So it does those compilations upfront before submitting the task. So you as a user never leave this pandas Pythonic world. Bodo takes care of the complexity of handling all the optimizations. So you can do distributed operations without going outside pandas, right? And then we'll see that as part of an example. So it's that whole approach kind of results in where we see that 115x, and this is just compared to Python, right? I'm not talking about Spark here. Compared to Python on a single core, when you take that same application and Bodoize it and say run it on multiple node or multiple cores, we see 100x, 200x performance gains without basically having to change a lot of your code. Now, I say that with a pinch of salt because we can't expect any code to be able to be Bodoized, right? There are situations where there are algorithms that have been written with pandas that are not really capable of running on multiple cores in parallel. So Bodo really can't help with that. So you do need at some time change your code so it can be parallelizable. But most of the situations, as long as you have written code that is standard pandas and you are doing vector-based operations, right? A lot of time people will do scalar operation like df.columns and then reading through it and then doing something on the column, creating an array, and then looping through those arrays, things like that. Those kind of things are not really parallelizable because the array, the same with Spark, right? If you collect an array that basically sits in one node, and you probably have to replicate it to do anything with that. It's a similar thing, right? So as long as you don't have that kind of operations going on, Bodo will be able to, just by adding this, execute your code in parallel, right? Any questions at this point? I just want to pause. I think there's a lot of information I'm sharing with you guys. Any questions? Okay, well, either I'm doing a good. Okay, go ahead.
Just to clarify, so this is usable specifically on anything that's already using pandas? Does it work if you pick a different ETL framework? If you're using like Koalas or PETL, can it do anything with those?
So at this point, no. But in the future, we will be. Our plan is to support. Hopefully in the future we'll be able to support other libraries as well. For example, like Koalas or PySpark. Okay. Hopefully, right? But as of now, no, you cannot. You have to be using pandas. So, and that's where the question comes in, right? If you are someone who's a PySpark user, should you be going to to Bodo and Pandas? Absolutely, if you're having performance issues, right? If not, nah, maybe not, right? So just a quick, when I say inferential compile, when I say compiling, right, what is going on inside a Bodo.ai score, right? So what we call Bodo is basically an inferential compiler. There's a compilation step that happens once you add that Bodo.jet decorator. So when you run a code, you will see that it will take a few seconds sometimes to get started, the actual execution to happen, right? So it will give you that additional overhead. But then the execution itself happens so fast that that overhead is minuscule compared to the gains that you get. It's especially true if you have large jobs that are you performing over, say, gigabytes and terabytes of data, right? That cost of compilation is very minuscule compared to the amount of time that will be saved. Okay. So basically what this does, it takes pandas code, it analyzes the code structure, it looks at schematics of the code. It will optimize any operations that are not being optimized. For example, a lot of the time in the notebook, we see with customers that they'll write statements that, like, they'll say, oh, df2 equal to blah blah blah, and then they'll never use df2 anywhere in that piece of code, right? Bodo will automatically skip over that. It'll know that, oh, this is actually not needed to be executed. So those are the things that will look at the code structure. So this can be skipped, this can be optimized. It will try to find the optimal data types behind the scenes to make your executions faster and much more memory efficient, right? And then it takes that data and then translates it using MPI to something that can perform in a parallel manner. Think of it like a group by, right? When you do a df.group by on a single core, now you have to take that operation across multiple cores. You can't just do a parallel, like you can't just distribute the data frame on 4 cores and then just do a df.group by and then expect you to get the right result, right? You would have to do some additional operations on top, like shuffling the data by the key to the right cores, and then the grouping happens so you can get the correct data output, right? So Bodo will internally behind the scenes manage all those complexities for you. For you, you are just doing a df.group by, which is a pandas operation across 4 cores, 8 cores, 10 cores, doesn't matter, 1,000 cores. Nothing changes for the user, right? And that's what the simplicity that Bodo brings a simplicity for the user, but also by creating that compilation stuff, it allows you to scale that performance gap that simplicity can't provide, right? So you have a simple solution, you can't scale, well, Bodo provides you that jump to be scalable, right? Actually, this is something that probably my CTO Ehsan can explain better, so I'm going to skip over this slide. It's just there. But if you guys understand number, this is based on number. So basically, the Python function gets converted to inferential representation or intermediate representations, which is basically a number concept. So if you have used number, it's very similar to what number does, right? It internally converts it to code that can execute much more faster in a parallel manner. So it'll do the same thing for data frames, it'll do this for series. So any pandas data frame or series functions can be leveraged by the end user, right? And then finally converts it all to a parallel accelerated code that can then now leverage MPI for distribution and distributed computing, right? And then that's the base difference. When I mentioned MPI, just a quick, like, how is MPI different from what Spark does, right? This is kind of what Spark does or Redo or even MapReduce does, right? Like I told, there's a driver application on the top. It kind of creates a plan on how to execute the code and then gives the code to the executors that then break them down into tiny tasks and then run those tasks. So there's these waves of tiny tasks back and forth that happen. What that does is that it creates a lot of overhead on CPU execution. So basically what happens is that your resources don't get used efficiently. On the other hand, with MPI, you have none of this, master worker kind of a paradigm, right? You have a simple rank-based paradigm. They are all equals, kind of. They are all at the same level. Rank, it doesn't mean any priority here. It just means an ID. This is a compute unit, right? And then this rank 0 is the 0th compute unit, rank 1. Rank 0 has certain importance in Bodo, where we kind of went and picked rank 0 to be the one that does most of the printing. So looks like if you have a print statement for a DF inside an MPI job, rank 0 will do the printing inside a Bodo function, just to make sure that we don't print the same thing multiple times. Like if I'm printing the execution time, you'll see that statement print. That will happen on rank 0, right? But basically, this is what happens. So this is when you say I need a 4-core execution, Bodo will or MPI will start 4 ranks, rank 0 to rank 3, depending on how many nodes you are on. That's the other thing that probably took me a little time to understand was when we say clusters on MPI, it's not a cluster of nodes, it's a cluster of cores. So you could have a cluster even on a single machine, right? So I can go ahead.
No, I'm listening. Sorry, go ahead.
Okay. So for example, this is it's something killed my Jupyter lab. That's okay. I'll bring it back up. But let's say I have a sample example of, right? So when you do an MPI execute, you can just, let's say I do MPI exec minus N4. I'm running this on 4 cores and I say host name. It basically will run the same command on all my 4 cores. And then I'm getting this like this thing printed out. I could do something much more complicated. Let's say I can do minus N4, and then I do minus C, Bodo, rank, right? This basically will print the rank of each processor. Hopefully it runs. I forgot print. Stupid. Right? So you should see the rank being printed, right? So you do not need this to be on multiple computers to actually scale this out. So you can think of it as that Bodo is not limited by how many cores are there. It kind of limited by how much memory is available on a single machine. So when I do this minus N4, the computer basically, MPI will basically take your machine and divide it into 4 execution units. Each one of them will have a single core available to it, but all of the memory will be available to these, right? So you can really do a large operation as long as you have enough capacity in memory to fit the data in memory, right? The other thing that kind of will differ from Spark is that if the data cannot fit in memory, it won't do any shuffling or spilling over, nothing. It'll just basically shut down, right? And that's where the expectation comes, right? So you don't do retries in MPI or with Bodo. You kind of run it fast. It runs in a few minutes. Sometimes a large operation. We ran a TPC benchmark on a 40,000 scale internally, and that thing returned in like 44 to 50 seconds compared to a Spark job that runs for almost 15 minutes, right? So the concept is that, okay, I'm going to take all the memory, I'm going to run it fast. If it fails, you just add more memory and restart, right? But this is the run so fast that you can do those things multiple times, right? Compared to where you have to wait 15 minutes just because, oh, I don't have enough memory, so I'm going to do a lot of spills and a lot of shuffles and be excruciatingly slow, right? So it's just a different concept of how we manage, how Bodo or MPI manages resources, right? So I can, with the community edition, I can go up to 4 without any license. If you have a license, you can go as many cores as is available. You could even oversubscribe if needed, if your data doesn't have a lot of memory, right? So I can go and completely distribute this across all my machines. Basically, you will see that the moment you do that, you'll get 4x performance gain on your simple data sets as well, right? So if you have a 100 MB file that takes you 15 minutes to process with pandas, you convert it to Bodo, run it with MPI-exec, and then it'll run, and you can expect it to run in up to 4 minutes, that's 4x faster. Any questions on this?
Yeah, so it seems that of course, Spark is like a general purpose engine, and Ray and Dask have their own specialization in the Python world. That Bodo's main kind of niche is high performance Python execution, regardless of what it is, that it does it extremely fast. And so I would come back and ask you that, compared to Dask, not Spark per se, but compared to Dask and Ray, do those still hold true in that I know that Spark has a high latency startup cost and coordination cost like you're describing in this picture, but compared to Dask and Ray, how does Bodo compare?
So Dask has the same problem. Dask is no different. It also creates multiple tasks. It's very similar to what Spark does. Ray does claim to have MPI. I'm very unfamiliar with Ray, but when you have to use Ray, again, you cannot just use pandas. You have to convert and especially if you want to leverage MPI-based stuff, you have to convert your code to Modin, their data frame implementation, and run it on any scale. So there's this kind of a code change again that has to happen, right? So Ray is probably the closest in how behavior to Bodo, but internally, even though they say MPI, they still have this task orchestration happening. Internally, it probably uses MPI for the communication and like for shuffling or any of those operations. I don't want to claim that I know that very well. I don't. But again, at the end of the day, it is the same execution architecture. While Bodo is kind of has nothing to do. We don't implement anything on the MPI side. We just leverage the MPI architecture, right? So the MPI exec that I'm doing here is not provided by Bodo. It is provided by your MPI providers. So you have several MPI providers like MPI-CH, which is an open source MPI implementation. There's Intel's MPI. Amazon runs with Intel MPI, where you can do elastic fabric adapters, where RDMA happens, random direct memory access. Basically, each rank can write into the other rank's memory directly. And you'll see that when you enable EFA on Amazon, your jobs will run 2x faster. They'll just fly. There's no we don't govern these things. What Bodo has done is that he leveraged all the MPI aspect and created a simple solution underneath pandas. So you as a user still use pandas, but then when you Bodo JIT the code, it gets converted to this complex MPI based code and runs on multiple cores much faster. So that's the difference. You do not have to change anything to scale your code. Right?
And I can see how this works very fast on the actual data because it's all in memory. But when dealing with tremendous amounts of data, we're always thinking about getting the data into the system and then obviously getting the data out. So there's obviously going to be some latencies related to getting information in to Pandas, and then there's the latency of, let's say, we have to send data back. So in that, there's different ways that in Spark we do that. Sometimes it's loading it via different connectors, and I know Python has all the different connectivity, but from a parallelizing the read and then parallelizing the write, at what point does that paradigm not work in Bodo? Like, have you?
So Bodo will parallelize the reads for you, right? So for example, I had an example. Unfortunately, I had an event happen. My disks became full on Sunday night. So for some reason, some other stuff that I wanted to show doesn't work. Let me show you a demo, right? Let me just go through code, right? So this is your regular Bodo a Pythonic workload, right? So this is your trip data, that I got from I think the Divi website or whatever, and this is how I would read a CSV file in Pandas, right? So I run it and it just loads the data. I can do some group bys, right?
Mhm.
Now, if I have to take this and run it, convert it to Bodo, all I have to do is Bodo.jit this, right? I can add an argument cache equal to true. And there are other arguments you can put. You can give hints like distributed. So you can say which data frame is, I want to distribute, or I can force it not to be distributed, things like that, right? When I do this, when I do Bodo.jit, it is reading the CSV file, but it'll read it in parallel, even at the read time. It uses MPI's capability. So it basically chunks or slices the data into however many cores I give. In this case, I'm running this still single core. You do not have to run Bodo multiple cores. There's there's no relationship between Bodo and multiple cores. Here I'm running it on a single core, so all the data will be in one core, it'll be in memory. So it'll be like you're running your actual Pandas code, right? No difference in that, right? Nothing has been changed. Internally though, when this loads, it will find out, how big is my MPI cluster. It'll know how many ranks are there, and it'll automatically divide that data across the ranks. In this case, there's only one rank, so it just becomes a single core execution. And as long as you're using or staying within a Bodo function, this data frame is represented in an internal Bodo format, right? So which is much faster, much more lighter in memory, much more performant. But the moment you return it, Bodo will kind of unbox it back to a Pandas data frame. So you can start using regular Pandas functions, right? So I can go here like this. In this case, I'm not doing any Bodo here. I'm just doing regular Pandas. Bodo handles it. Now, if I take this and let's say I have to run it on a cluster, we internally use IPyParallel for the clustering. So if you want to do interactive, either you can do MPI exec, like I showed you on here, right? Or you can just come in and this code is just copied from our Bodo doc, and if you go to the Bodo documentation, you have an example of interactive Bodo cluster setup. You just install in your Conda environment IPyParallel 7, and then just run this piece of code. And then now you can do multi-core execution using this %px line magic. Let me run that. So that will start a 4-core engine in Bodo. I'm sorry, a 4-core engine inside your Jupyter notebook. And you can start submitting tasks, right? So I can go and submit this task on to the cluster, and you should see some performance gain. The first time it's a little slower because of the compilation, but then the following execution should be much faster. Now, if you see the data frame has been distributed across multiple cores now. That's why you're seeing these 4 different outputs. So Bodo will, the moment you read it, even from a database, it will do a count. It'll kind of figure out how much data is there, and will kind of distribute it across all the cores. So it does the parallelization read. We have done some optimizations internally. So internally, it uses PyArrow for all the representation. So there's a lot of performance gain over regular Pandas when you're reading data, especially if you're using more, data analytics optimized storage formats, like let's say Parquet or one of those will perform a lot better than CSV. Even with many call database, like if I do a pd.read SQL against the Snowflake database and say 1 million rows are being returned, pandas.read SQL will take say 15 to 20 seconds, while if you just do a Bodo.jit on it, it'll come back in 2 to 3 seconds, because it uses the internal, automatically optimizes it to use the Snowflake connector code and convert to using the, if you have done it, you must have. There's a separate code that you can do with Snowflake to convert it to Pandas data frame. So you'll automatically change your code to use that approach. So you'll right away get that performance improvement. And you can easily go between a pandas data frame and a Bodo data frame, right? So for example, I can let's say if I want to do a pandas operation where I add let's say a column here, let's say, or I want to do an operation on it, like something like that, started at copy. I'm not so fluent with pandas, so these things don't occur to me very well. What needs to go where? But let's say I want to do something like this. I can still do this. I have to remember to put px here, because if I don't, it will run on your Jupyter instance and not on the cluster, of course. So when I do this, this will still run in a parallel manner across all the 4 cores, right? But it will run on each core individually. So I cannot go and do a df.group by here, because I will not get the right answer, right? I won't get the right answer, because it's possible that some data for this guy is on core 2 and some is on core 1. So when you do the df.group by, actually let me do that. Okay, that's probably a better example. Let's say if I go and do this df.group by, I'm not going to save it. You will see that it's being repeated across multiple cores and your results are different, right?
Mm-hmm.
This is a pandas set executing on individual cores.
Mm-hmm.
But if I do the same thing within a Bodo JIT function, I run it, you see it kind of moves the data, it kind of shuffles the data so you can get the right answer for your result set, right? So, so you can still work outside of the Bodo JIT framework. Once you have a data frame, you can still do parallel compilation. Like I use it sometimes where Bodo currently doesn't support every pandas operation, right? So if you go into pandas operation, there's a few unsupported operations still out there that we are, so normally we didn't use it because most of like people that we came across didn't use it. But sometimes you come across a customer, like we're coming across customers who are using a lot of pivot, right? So if you want to do a pivot and Bodo doesn't support it, this is an alternative, right? So you could commit and you can actually run your pivot operations here. There's something called apply that a lot of our customers do. So we kind of took that in and optimized it, where if you have apply, those UDFs don't perform very well in pandas. There's a lot of overhead in when you're running those, performance is not so great. Just by putting add Bodo JIT around functions that do the apply, customers have seen or users have seen 3 to 4x performance gain, right? So it kind of takes this, and now you're doing a distributed operation across multiple cores very easily, right? If I remove this, it will just do a regular pandas operation at that point, right? What else? Another thing that we change is that if you have to read multiple files, CSV file especially, with Parquet, the behavior is default. If I'm doing read Parquet and I pass in a argument, I can actually pass in a file name or I can pass in a folder. It'll work. Pandas does that the same, so that behavior isn't different between Pandas and Bodo. But in case of the CSV, Pandas requires you to pass in a file, actual file. So when you have to read a directory full of CSV files, you probably see users kind of getting those CSV files in an array and then looping over them, reading them in data frames, and then concatenating them, right? You do not have to do that with Bodo. You just pass in the data frame or the folder, and then it will load all the CSV. It will actually distribute the CSVs across. It's a very even distribution. So if there are 8 CSV files and you're doing a 4-core execution, it will execute it across 2 nodes. This is the portion that is not working for me because of my disk being full. For some reason, it's giving me errors. It just gets stuck. I'm sorry, I can't demo that, but you can do it on your own machines. All you have to do is this, and we'll read all the files in that folder, even though it's CSV, doesn't matter. But that kind of is a behavioral difference that Bodo has compared to regular pandas, right? Any questions still here? I hope this was self-explanatory. Okay, we do also have a Bodo platform on AWS. So you can go into AWS and kind of register and do a subscription, and kind of attach your VPCs to the Bodo control plane, and that will allow you to just launch clusters by here. And then once the cluster is launched, you can go into the notebook thing, create a notebook environment, attach the notebook to the cluster, and start doing your data analytics here. For example, I have an example here of a TPCH query that I did, benchmark on a SF10 data set, scale factor 10 here. And overall, you can see most of the queries will finish in less than a second, right? When I did the same thing with Spark, I can see that I can see almost a 26 to 30x performance gains compared to open source Spark. For example, I captured those in a TPCH document somewhere. Let me see if I have that. I might have deleted it. Right. So again, this is not a competition against any of the providers. It's just showing the value of Bodo is that on a same SF10, I did it on a 3-node Cloudera cluster. I didn't do it on our platform, but it's just our platform should be much faster because the Cloudera cluster was on EBS with data in HDFS. S3 should probably give you better performance than what you see here, both on Spark and Bodo side. But roughly, like you can see this query, my biggest benefit query was where I see biggest gain is Q18, where the query is like in Spark, it's fast, but it's not as fast as it takes around 2 to 3 seconds or 26 seconds in Spark, but in Bodo it kind of takes way less time. For example, Q18, it's like almost heavy gain. That's mainly because of Spark having to do a lot of shuffles internally, but Bodo has the data in memory, so it's pretty fast. But I've kind of ignored those. That's why they are red, because these are outliers. Now there could be something that Spark could be doing. Maybe it didn't load a data frame, so it's kind of spending time in reading that from the disk. So it kind of, I see something in the chat. So yeah, coming back. Yes, you can. There is a resource allocator called Slurm that can be used. You can also use the MPI exec capability to allocate CPU. There's no efficient way outside of Slurm to allocate RAM to multiple users. So multi-tenancy is something that we are working on. But overall, cluster sharing is okay because your jobs will come back in seconds compared to several minutes with other options, right? So overall, you should still be fine, if your users are using the entire cluster. You can also use Docker or something on top to create the entire framework. Like, a user comes in, he asks you, let's say he wants 10 cores with 100 GB, you basically create those on a Docker Kubernetes instance and just give it to him. So he plays within that environment. So you could use something like a Docker also to manage that, right? But overall, what you get with Bodo is this, where you get kind of my last, obviously you get this kind of a jump where your kind of MR was highly disk based, IO bottleneck. Spark kind of revolutionized it by being completely in memory, but then kind of this is a jump over that Spark kind of paradigm to a more performant HPC style kind of performance, where you'll see a lot of these things will come back in sub-seconds, right? We are also offering a Bodo SQL solution, which is in its beta stage. So if you go to the documentation. I unfortunately don't have a demo for it, but you can install Bodo SQL from Conda, and then now you can like register tables. It's not as similar as Spark is. We have to create all those utilities. Like our next task is to create a Metastore connection, so you can use your Hive Metastore tables directly. But once you do that, you can just kind of start running queries like this. So you can take your existing SQL workload like Hive or PySpark or whatever. This probably would fit the Impala's paradigm a lot because it's very similar. Run the query as fast as possible. If it doesn't fit what the daemon sizes are, just crash, right? It may not work that well with Hive users because of the fact that Hive is a long running thing, right? Even if something doesn't fit in memory, it'll just take its own time, sweet time to finish. So maybe some of those users may not like it that much. It still can be used as long as you give it enough memory, right? So there's a Bodo SQL offering as well that's coming in. So it kind of gives you that step up. And main reason that you want to use Bodo for your data engineering, also data science use cases, we do support sklearn. So if you have a sklearn regression training that you're doing, you can add Bodo JIT around it. It will automatically convert it to XGBoost and do distributed training for you. So there's probably an online demo somewhere. If not, I can put one on. Just let me know and I'll put one on my GitHub that you guys can utilize. It's simple. It's simple because you use existing known technologies. You can use Python or SQL in the future, right? There's nothing really needed for you to scale the data, right? You're using what is known to you. Bodo is pushing everything under the hood from the scalability aspect, right? No special thing needed to deploy that code to production. What you write in your laptop is what you can take to your distributed environments, right? No need to rewrite to PySpark or to Scala or to some complicated logic or Dask or Modin or any of those things are not needed, right? But it still will guarantee you that extreme performance that you need, right? Again, from your laptop's data to all your data, right? Again, nothing needed, right? You just take your code that was running on a smaller data set, take it out, run it on larger data sets. This Bodo can scale up to 1,000 cores, easily. I'm just saying 1,000 because I've not seen anybody else use more, but I'm pretty sure you can use more. MPI codes on supercomputers run on like tens of thousands of cores normally. So you can take it up as long as the data can scale. So there's some, obviously, it's like the freight train, right? If you can use a freight train to carry a lot of data, but it can, let's say, transport 100 metric tons like in an hour from point A to point B, and then you get performance. But if you have only 50 metric ton, doesn't matter if you use a freight that train that can carry 100 metric ton, you won't get your speed down from that 1 hour limitation, right? So there's certain low level things where the gains will stop depending on your data volumes, but overall you should see performance gains, right? And this is the most important thing that I saw as a benefit is the maintenance and aspect of it, right? The configuration hell that Spark users have to go through, right? You have to kind of tweak the job, or it's affected by small file sizes or too many partitions. Okay, I want to do coalesce, or I want to run something like shuffle partition configuration has to be set up. Or I set it up nicely to work for a certain job, kind of conflicts with some other job that is running. So there's this configuration hell that I've seen Spark and Hive users also go through. You do not have to handle that anymore. I have not shown you one single line of configuration. Everything is code, right? But there are configuration that is just to change behavior, but it doesn't change performance anyway. Right? All you are doing basically in Bodo is calculating like, hey, I have this data size, it runs in 10 minutes on one core. If I have this much and I have an SLA of 1 hour, this summer, and how many cores do I need? right? Simple as that. Obviously, memory also falls in place, but kind of you see most compute options available these days have a lot more memory than core. It's very easy to get memory, right? So that's the only thing that you have to look at. Everything else is taken care for you by the platform. So I think that's where I'll stop. I don't mind staying here for 5 more minutes if you have any questions, right? That's it from me. I think we should stop here.
Great.
Awesome. Thanks, Karthik. Raul,
Yeah.
did you have something to add? I saw you on mute.
No, I just wanted to say thanks. It's always nice to see new ways of thinking and new technologies, especially since our problem of data management isn't going away anytime soon.
Right. Yeah. And absolutely. I think I see data stacks as another time series on top of data stacks, or a NoSQL kind of a database has been a constant problem. I think this is where something Bodo can fit nicely to, like calculating these rolling window aggregations and super fast times, and so things like that, is absolutely where Bodo fits well. Any of your data engineering problems, right? I don't want it to be a salesy thing. That's not what I'm trying to do. I'm just trying to,
Yeah.
I think people using it in the community is what make Spark is big. Spark is Spark because of the community, not because of Databricks. So, and that's where the community comes in, and we have a lot that a community can contribute to a platform like Bodo, especially on usability aspects. Like, try to use it, see what issues you have. You have my email addresses here. Just send emails to me with your questions or problems that came across. I can try to assist you. And the feedback helps us in improving the usability or the user experience of the product immensely. So again, thank you very much for allowing me to speak.
Yeah, thank you, Karthik. Very much appreciate it. And thank you everyone for joining today and contributing some good questions. If you joined us on YouTube, don't forget to like and subscribe. And yeah, once again, very much appreciate you coming on and explaining Bodo.ai's capabilities and doing some comparisons and showing us how it can optimize some of our workloads.
Yeah, and if in case there's an interest to go deeper into the technology, with you guys, I can bring in, one of the engineers, or Ehsan, and they'll be very, very interested in speaking and showing more. What I've shown is just very small aspect of what Bodo is capable of, but we can absolutely do that as well. Like go more deeper into the technology itself if needed.
Mm-hmm.
All right.
Great.
Yeah, thank you guys. And thank you, Karthik.